VLPSos here. This is a video lesson for Python programming. Data type float. These lessons are intended to be paused so that you can practice. So far we have seen the following data types: integer, string, and Boolean. And I've made an example of each and assign them to a variable. There is a new type called float. I'm going to assign to the variable name a float, a value of 30.6234. This is a float because it's a number that includes a decimal point. We can think of this number being stored in memory, its integer or digit components, and what floats is the position of the decimal place to make it into a number that includes a fractional part or a fractional component. And we can print and format using floats. For example, we have data types, and I'm going to create a string that includes each one of those variables using the formatting technique of using a symbol to stand for a value of a particular data type. S for string, I for integer, R for a Boolean, now the new one, F for float, and the dashes or the minus signs are only to separate these values when we see them printed. We have to supply the values of those variables. What comes first is the string associated with the %s, and then the integer, the Boolean. B is for binary, so we use an R for Boolean, and then the float. I'm going to run and take a look at our output. Notice that we have those 4 values that are separated by the minus signs, and the float is there, but something happened with the float. It has a couple of extra zeros that are unnecessary. They don't change the value of the number, but they're part of the float number as evidence of it being stored in memory with those zeros. It's formatted that way, and it may be unpleasing or unuseful to format with floats in this manner. Floats kind of have an issue with formatting. They require more sophisticated techniques. So notice the formatting, lots of extra zeros, which is evidence of how the number is stored in memory, an integer with the position of the decimal point floating around, which is how it gets its name. We can create floats with division. We can print the mathematical operation 3 divided by 5, and when we do, we can see that the output is 0.6, which then would be a floating point number. We can confirm that with the type function. Type returns the type of data in its argument. So if we put the 3 divided by 5 into the type function and print the result, we can see that the program reports that it is of class float. And we have the comment for the lesson. Notice division creates a float. We need to be aware of data becoming float because many functions behave differently with floats or not at all. We'll be using functions in programming quite often that require integers to be their input, and they would break if they didn't have an integer. But the data or the numbers and the variables that we often use in programming take advantage of floats being able to handle fractional parts of numbers. So we'll need to pay attention to variables that we wish to be type float, but at the moment that we use their values in functions, we need to convert them to integers or an integer form. I can take an integer, in this case the one that I previously defined, called an int, and I can divide it by 1, which will not change its value, but it will change its type. So this is an example of an integer becoming a float through the programming. And I can confirm this by putting an int divided by 1 into the type function and observing the result. We can see that the integer divided by 1 looks like 5.0, and it is confirmed that that integer became a float, which then, if we were to use this in a program with some functions, might cause a break. I can confirm that the integer that I called an int is still an integer in of itself. So I've printed both the type when the integer was used in division, though division by 1 didn't change the value, but it didn't also change the integer and int. It's still an integer. It only became a float in this operation. I can do the same thing by multiplying. Multiplying by a fraction will turn something into a float. So if I multiply by 0.1, which is itself a float, this is an example of an integer times a float, and the result is not only a value, but a data type that we will observe on running. When I multiplied by 0.01, the integer, the product of an integer and a float became a data type float, and I can confirm that in the type function it's telling me. Very often we will use the integer form of a float variable. So if it's problematic that we use float in some functions, then we need to be able to turn it back into an integer when we wish to use it. Here's an example of that. I'm going to print a float that has been put into the integer function. We could think of this as printing the integerification of the number by a float. When we do, we can see that the value of a float in integer form is 30. Now the initial value of the float was 30.6234. You may have expected that if it was going to make an integer out of that, it would round to the nearest integer, but it didn't. The int function truncates. It doesn't round. It just simply cuts off the part of the number that is past the decimal. And we can observe this, kind of exaggerate that situation by printing the integer conversion of the float 5.999 with many nines. 5.999999 is extremely close to 6. But if we put that float into the integer function, it's just going to show us the whole part 5. It does not round. And we say that the int function truncates the float value. We could also use a function to turn something into a float. For example, the integer 10, when put into the float function, will create the float form of 10, which we'll observe when it prints. And we can see this last line of code is 10.0. It's obviously a float because it contains a decimal point, but its value is still equal to 10. And now that we can work with floats, we need a better way to format output, because using this form of formatting strings is problematic or slightly ugly because it often adds extra zeros and makes that number look very large in the print. There is certainly a different way to format that we will have a lesson on soon. Now you saw the int and float functions being used to convert data types. How does the string function behave? Write a line of code that takes advantage of the string function to make using a float in a string look better by getting rid of the unnecessary zeros that we saw in the beginning. Try it out.